students, to the homework help video. These problems here, let's jump right into these right away. I know this one's really hard to see, and I apologize for that, but if you'll look in your book, on page 231, you will see the problem says to do the following. The U.S. Department of Transportation requires surveyors to place signs on steep sections of roads, okay? The grade of a road is measured as a percent. For instance, the grade of the road shown below, if you look in your book, you'll see a picture, is 6%. Now, what is the slope of the road? Okay, well guys, this is a pretty simple problem. I want you to take a 6% grade, and I want you to convert that over to a slope. Well, it's actually pretty simple to do. First of all, 6% means what, guys? 6 over what? 100, right? And then if you reduce that, you will get 3 over 50, right? So there you go, that's it. A 6% grade means you have a slope of 3 over 50. That means, let's pretend we're dealing with miles, okay? Let's pretend we're dealing with feet. For every 3 feet you drop in the road, you will travel horizontally 50 feet, okay? So in other words, here's the road, okay? If from here, there's the road going downward, okay? So, if you could draw a right triangle, if you drop down 3 feet, then you traveled horizontally 50 feet. There you go, you did it. It's that simple. It could be feet, yards, inches, miles, whatever. So what is the slope of the road? 3 over 50. Now explain the relationship between the grade and the slope. Sure. The relationship is simply this. The higher the percent, the steeper the slope. And that's it. Makes sense, okay? So the last example I used was a 6% grade right here, 6%. If it was a 10% grade, then that would be steeper than a 6% grade. Alright, number 52. Alright, now the directions say to give the units of measure for the rate. Okay, now guys, on all 3 of these, stop and think. Okay, stop and think. First of all, we're dealing with X minutes, Y inches. Now, they want us to give the rate, okay, or the rate of change, which remember, a rate of change is the same thing as a slope. So when you're dealing with slope, or, are you listening? Rate of change, remember a slope is a rate of change. It's the change in the rise in relationship to the change in the run, okay? So, listen carefully, please. Think of your slope formula, y minus y over x minus x, right? So in other words, your y's are what goes up top. So your y's are your inches, so your rate's going to be inches per minute. Now, first of all, do you see how I got that? In slope, or your rate of change, y's go up top, x's go in the bottom. Your y is the inches, so inches go up top. Your x is the minutes, so your minutes go in the bottom. Now, how do you find the change? Well, you subtract. Here's your x and your x. 2 minus 9. Sorry, I apologize. Up top is your y's, so we do our y's first. Sorry about that. 2 minus 23. Your x's would be 2 minus 9. So you end up with negative 14. Boy, I'm really struggling, aren't I? Sorry, guys. Negative 21 over negative 7. A negative over a negative is positive. 21 over 7 is 3, so it'd be 3 what? 3 what? 3 inches per minute. There you go. That's the rate of change. Got it? That's the rate of change. It's changing 3 inches per minute. X's are up top, X is in the bottom, your Y is dollars. So dollars is up top, okay? X is in the bottom, X is years. So our rate is dollars per year. Now, my Y's would be 5 minus 69. And my X's would be 3 minus 11. So, 5 minus 69, or positive 5, negative 69 would be negative 64. Positive 3, negative 11, it's negative 8. Negative over negative is positive. 64 over 8 is 8. That's $8 per year. There we go. That's the rate of change. $8 per year. And then lastly, number 53, up top would be liters, because that is my Y. And the bottom would be seconds. So my rate is going to be liters per second. Now we're going to do something a little different here. Watch this. I've always told you guys it doesn't matter which ordered pair you put in first or second. Okay, so now I'm going to kind of flip-flop this. I'm going to use this Y first. It doesn't matter. 14 minus 44. There's my Y's. And my X would be 32 minus 53. And you still get the same answer. It doesn't matter. Okay, 14 minus 44, that's a negative 30. 32 minus 53, that's going to be a negative 31, 21, negative 21, I believe. Yep. Negative over negative is positive. 3 goes into both of those. 10 sevens. Now, since we want to get this down to a rate, I'm going to go ahead and divide 7 into 10 to get a decimal. So 10 divided by 7 is 1.43. So your rate's going to be 10 divided by 7, 1.43 liters. Liters per second. Alright? Liters per second. There we go. That's your rate. Okay. So, not too difficult. Moving on to 55. Now, in 1870s, the cable car system was built in San Francisco to climb the steep streets. It was the site of the first cable car used for public transportation in America. Calculate each labeled slope from left to right. Guys, this is so easy. Okay. See the slope here going down in red. So the first slope in red would be rise over run, which would be 1 over 20. 15 goes into both those. 15 goes into 15 once. 15 goes into 30 20 times. Okay, so there's the first one. It's so easy, guys. Okay, here's your green. Here's your green line right here. So students, to find the slope of the green line, it's rise over run. All the work's done for you guys. Really simple. Rise over run. Let's see, 15 goes into both these. 15 goes into 45 times. 15 goes into 30 20 times. So your slope is 3/20ths. And then for the blue line right here, you have rise over run. 50 over 300. Knock off a 0. 5 over 30 is 1/6. And there you go. Okay. Really, really simple. Right, moving on. 56. A space shuttle achieves orbit at 9:23 a.m. at 9:23 a.m. Period. At 9:31, 8 minutes later, it's traveled this far. Find the rate of change in miles per minute. So I want my miles up top. I want my minutes at the bottom. Let's find the rate of change. So it's traveled how many miles? Well, it started when it got into orbit. That's when we started our time. So it traveled 0, and then it traveled 2,309.6 miles. So that's how many miles it's traveled. That's how many miles it's traveled in how many minutes? Well, we started at 9:23. We reached this many miles at 9:31. That's 2.7 miles per minute. And that's your answer. Okay. Alright, moving on to page 245. Here we go. Snow fell for 9 hours at a rate of a half an inch per hour. Okay, students, had to pause the video there. I'm not sure exactly what I said, but snow fell for 9 hours at a rate of a half an inch per hour. Now, before the snowstorm began, there were already 6 inches on the ground. So this equation here models the snowfall, and it should, right? Think about it. You start off with 6 inches, plus you're getting a half an inch per hour, and X stands for your time, okay? X hours, okay? So, what is the slope of this function? Okay, no problem. You know by now that when a linear equation has y by itself, the slope is the number with x. So there we go. The slope is 1/2. Okay, now, what is the y-intercept? Well, you know by now, when y is by itself, this constant term is your y-intercept or your b, okay? So your y-intercept b is 6, okay? Now, explain what the slope and the y-intercept mean. Okay, fine, no problem. First of all, let's talk about the slope. Now, slope 1/2 is your rate that the snow is falling. And that's pretty easy to understand, is it not? X is your time right here. X is your time. So every time you put in an hour, 1, 2, 3, 4, whatever, it gets multiplied by 1/2 because every hour the snow goes up 1/2 an inch. So your slope is the rate the snow is falling. Now, what is your y-intercept? Well, think about it, guys. Your y-intercept means you put basically putting 0 in for x, right? Like I've taught you to do when you're trying to find the y-intercept. So what they're saying is when 0 hours have passed, you have 6 inches on the snow. So 6 is the initial. Your y-intercept, 6, is the initial amount of snow before it started snowing. So your y-intercept is how much snow was on the ground before it started snowing. Now, graph the amount of snow on the ground during the storm. 58. Okay, no problem. That's easy. We know how to do this, don't we, guys? I mean, we've learned. Well, first of all, we know that we're going to start off with at 0 hours, there were how many inches on the ground already? 6, right? Correct. And it snowed for how many hours? 9 hours. So let's put a 9 in for x. And how many inches do we have? Well, it would be, let's see, put a 9 right here for x. So 1/2 times 9 plus 6, that would be 4.5 plus 6, that would be 10.5. So 9 comma 10.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Go over 9. 1, 2, 3, 1, 2, 3, 1, 2, 3. So go over 9 and up 10.5, which is right there. And there's your line. Now notice I did not put arrows on each end like this and this. Okay, this is a word problem, so the graph should match the statistics given to us. So x is my time. So I started at 0 hours and I went to 9 hours. At 0 hours there were 6 inches. At 9 hours there was 10.5 inches. So there's the graph. Now, in Apple County School District, school is canceled if there is a foot or more of snow on the ground. So, would they cancel school? Well, no, because a foot is 12 inches, and there's only 10.5 inches on the ground. So, would they cancel school? No, they would not. Okay, alright, moving on to 60 and 61. The cost of a long-distance phone call is 87 cents for the first minute, and 15 cents for each additional minute. Let C represent the total cost of a call that lasts T minutes. And actually, guys, I'll be honest with you, we are not doing scatter plot. dots until chapter 5. I'm not worried about that. What I would like you to do is I would like you to find the slope and tell what the slope represents. Okay? So let's stick together on this and let's do this. Okay? First of all, understand I'm going to write an equation first of all. Okay? I'm going to say the cost of a phone call is 87 cents for the first minute plus 15 cents. Okay? This is where it gets really confusing, so pay attention, okay? A lot of students would put T for time here, alright? And students, here's why that would not work. If you'll listen carefully, I will explain this to you. This does not work because, think about it, if you talked for 1 minute, what's your total cost supposed to be? 87 cents is what it says right here. 87 cents for the first minute, okay? So if you talk for 1 minute, it should be this much. So come over here and put a 1 in for T, and look what you get. You get 87 cents plus 15 more cents. You get 92 cents for the first minute. That's not right. That's not right. So guys, we cannot use that model. However, if you put T minus 1, now watch how this works. Now, when you put 1 in for T, what's 1 minus 1? 0. What's 0.15 times 0? 0. And you get 87 cents. Now, if you talked for 2 minutes, what is your cost supposed to be? Well, it's supposed to be 87 cents for the first minute plus 15 cents. So it should be $1.02. Okay? Let's see if it is. Come over here and put a 2 in for T. Alright? T minus 1, or 2 minus 1 is 1. Put a 2 right here. 2 minus 1 is 1. 1 times 0.15 is 0.15 plus 0.87 is $1.02, so it works, okay? And so on and so forth. Now, you technically did not have to write that function, but I thought it was good for you to see that, just to stretch your minds and make you think about that, okay? But if I want you to find the slope, here's what you would put down. You would say, okay, for 1 minute, comma, it's 87 cents. For 2 minutes, comma, it's $1.02. Now that's 2 ordered pairs, is it not, students? Sure it is. Okay, so I can find the slope of this pretty easily. Remember, it's y minus y over x minus x. When I say slope, that's the same thing as saying a rate. So y minus y, that's $1.02 minus 0.87. Then x minus x would be 2 minus 1. So I would get 0.15 over 1, or exactly 0.15. So did I find the slope? Yes. What does it represent? Well, look right here, guys. It represents the rate. It represents your cost per minute after 1 minute. This is your cost per minute after 1 minute, because the first minute's 87 cents. Okay? Alright, guys, I know these are pretty, not easy. I know you gotta think on these, okay? Alright, 64, you start home. The directions say to graph the situation, okay? We're gonna graph it. So, you start home and you drive 55 miles an hour for 3 hours, where D is your distance from home, okay? So here we go. D is your distance from home. So your distance equals what? You start from home and you drive 55 miles per hour for 3 hours. So students, you the model we're going to write here is the distance you are from home. So right now when you start off, you're starting from home. So how far are you away from home? Well, you're 0. And then plus, you're going to increase your distance 55 miles per hour. So 55 times your what? Time. Okay? So there's your model, guys. When you start off, you're how far from home? 0. miles an hour. So every hour, your time is in hours. Every hour is 55 miles. So 0 plus 55t is just 55t. So I'm going to graph this very quickly by simply putting in a 0 and then putting in a 3. Now, Mr. Earhart, why would you use a 3? Because it says here you drove for 3 hours. And when you started, you were at 0 hours. So put a 0 in for t. 55 times 0 is 0. And then put a 3 in for t. 55 times 3 is 165. So on my y-axis, I'm going to go in increments of probably 20, 20, 40, 60, 80, 100, 20, 40, 60, 80. And I'm going to go over 3, 1, 2, 3. So we're at 0, 0. And then we're over 3 and up. 1, 2, 3, 4, 5, 20, 40, 60. About right there, just approximately there. And there's my graph right there. You don't put arrows on the end. That's it. You just stop. You don't go like this. You don't go like this because it's a word problem, so you want to have it match the word problem. And there you go. You did it. So this graph shows you how far you are away from home based on time. This is your t-axis and this is your d-axis. Alright, now let's try it again. Only now it's a little different. You start 165 miles away from home and you drive towards your home at 55 miles an hour. Got it? Where d is your distance. Now before the last problem, look. D was your distance from home. Here it says d is your distance from your home again, but this time you're not starting at home. You're starting away from home, okay? So at the very beginning of the problem, you're how far away from home? 165 miles. Got it? See it right here. Now you're driving toward the home, so this distance is not going to get larger, it's going to get smaller. Over here, your distance got larger because you were driving away from your home, so the distance from home got larger. Here, your distance is going to get smaller, so we're going to subtract, and that's 55 miles per hour times every hour, so t, there we go. So every hour you travel 55 miles, we subtract that from 165, we're getting closer and closer to home. So there's my model. Now let's graph it, okay? Again, I'm going to put in 0 because that's where I started. I drove 0. And I'm going to drive for 3 hours. Now, put a 0 in for t right here. 55 times 0 is 0. 165 minus 0 is 165. Now that makes sense, doesn't it? Because it should. At 0 hours, you are how far from your house? 165. Makes sense to me. Now put a 3 in for t. 55 times 3 is 165. 165 minus 165 is 0. So there's your 2 points. Alright. So my first order pair is, this is my t-axis, my time. This is my d, my distance. Going in increments of 20. 165 is about there. Okay, going in increments of 20. So 0, 165 is there, and 3, 0 is there. So there you go. Draw your line, and you're finished. And that makes sense. You started at 165 miles, and you went down to 0 miles right here. 0 when you're done 3 hours later. Okay? Back that up and watch again if you need to, okay? Alright, moving on to page 100 or 260. Here we go. Is the projected high school enrollment a function of the year? Well, let's see. Let's stop and look, okay? Projected high school enrollment is blue. Do you see that right there? It's in blue. And so we're going to look at this blue graph and see if it's a function. Now remember, I've taught you to do this. You're looking for a situation where there's a point directly or above or below vertically another point. If that happens, then you do not have a function, okay? Well, students, nowhere can I see that happening. Every point on the blue graph is not directly above or below another blue point, vertically below. So, is the projected high school enrollment a function of the year? Yes. Same thing with the college. Is it a function of the year? Yes, it is, because look at the red points. There are no points directly, there are no red points your x. Okay? So what they're saying is estimate the number of high school students for 2005. High school, that's blue, 2005. So here we go. Notice this is years since 1980. Got it? Years since 1980. So 0's 1980. That's 85, 1990, 1995, 2000, 2005. There it is. So at 2005, what's the projected number of high school students? Well, Blue's high school looks like it's going to be, this is in millions, it's going to be barely above 16 million. I'm just going to say 16 million. It says estimate, that's good enough, okay? Now they want you to estimate G of, or in other words, 2005, G of 2005 for the college students. So here's 2005. College is the red. We go up to the red. That's pretty close to 17 million. Now I want to say one thing here. You might be a little confused about the functional notation. Now hold on a second. Remember, we studied this. If I said f of x equals 2x minus 5, and I told you to find what? F of 5, what does that mean to do? It means to put 5 in for x, and then evaluate. So f of 5 would equal 10 minus 5, 5. That would be the same thing as 5 comma 5. Well, that's all they're saying here. They're saying your x number is 2005, so go over to 2005 and find your y number. G of 2005, same thing. They're saying here's your x number. Go over and find your y number or your g number up here. That's all they're saying. Okay? Students, I really hope that this homework help video has been a help to you. If you have any questions at all, please don't hesitate to contact me.